Hello, Math 8 students. So what I'm going to go over right now is how to solve for angles when you have two parallel lines that are cut by a transversal. And this example actually has two transversals, so that just adds a little bit of a layer of complexity. But totally manageable from what we already know from section 3.1 about parallel lines, transversals, and their angles. One piece of advice is to have your INV open to, and I'll see if I can find it in mine. So you have a green piece of paper. Yep, right there. It looks like that. And that's going to have a lot of that really important vocabulary with a definition and a little picture for what we're going to use to solve this problem. So this is called a magical puzzle. And basically what we're going to do, and it's pretty cool actually, we have two parallel lines, M, this one, and N, this one, and those are cut by two transversals, this one here, and then this one here. And so those two parallel lines, M and N, are cut by two transversals. And by just being provided with two angle measures, this angle measure is 44 degrees here, and that was given. And this angle measure here is 52 degrees, and that was given. Just with those two angle measures, I can determine all the other angles on this mathematical puzzle. And I'm going to do that using the ideas that are in this green sheet here. So definitely have that handy. All right, so let's get to it. So let's start at number 1. Very good place to start. I can see here that this angle 1 shares space on a straight line. So I know that 52 degrees, this angle, plus angle 1 are going to add up to 180 because they're on a straight line. So I'm going to use the idea of supplementary angles to solve that, solve for that angle. So if I go ahead over here and think about that, I'm going to say, okay, well, for angle 1, I know that I have 180 degrees as a straight line. So I'm going to take away the 52 degree angle here and see what's left over, because that's going to be angle 1. So, a 180 minus 52 is going to equal, so let's see here, if I do that on my little scratch piece of paper over here, I'm going to be left with an angle that's 128 degrees. So I know that angle 1 is going to equal 128 degrees. So let's put that in that space there. Not quite so big. And 28. Perfect. All right, so now I know angle 1 because I use the idea of supplementary angles. Let's do the same thing for angle 2 over here. Because angle 2 is on the same straight line as this angle that measures 44 degrees, I can do the same thing. I can use the same principle of supplementary angles to understand what angle 2 equals. So I'm going to take 180 degrees, that's that straight line, and I'm going to subtract the 44, and what's left over is angle 2. So if I do that, I get 136 degrees. And remember here, I'm being bad and not writing the degrees. So just keep that in mind. So that's 136 degrees. So let's get that into the right place. Okay, so now I've solved for 1 and 2 using this idea of supplementary angles. So to solve for angles 3, 4, 5, and 6, I'm going to use the idea of vertical angles. So vertical angles, if you refer to your book over here, is when two angles are directly across from each other. So angles 1 and 3 here, those are vertical angles. They're directly across from each other. And whenever they're vertical angles, they're going to equal each other. So I know that because angle 1 and 3 are directly across from each other, they are going to equal the same thing. So for angles 3, 4, 5, and 6, I'm going to use the idea of vertical angles. All right, so with this idea, I can really just fill in what these equal. So for angle 3, it's a vertical angle to angle 120, the angle that equals 128. So I'll just write in here 128 and then get it into the right spot here. It's the hard part. And then same thing. Angle 4 is directly across from its angle that measures 52 degrees. So I know that that angle also has to measure 54 degrees because it's directly across, or excuse me, 52 degrees. So I'll just take that, move it into its spot. So I'm using this idea of vertical angles. Same thing over here. So if I look at angle 5 is directly across from angle that measures 44 degrees. And so I know that that has to also equal 44 degrees. So let's put it in there. 44. And move it into its spot. Right here. And then same thing for angle 6. It's directly across or vertical from angle 2, which equals 136 degrees. So I know that angle 6 also has to equal 136 degrees. So I'll just write that in there. All right, so now we've solved essentially 6 problems with very little work, which is nice. Let's go down here to 7, 8, 9, and 10. What I'm going to do for that is I'm going to think about that rule that we came up with way in the beginning of the year for the internal angles of a triangle. I know that if I add this, so if I consider this as a triangle, it is a triangle. It's got 3 sides. It's a triangle. And I know that if I add 52 plus 44, whatever angle 7 equals has to all together be 180 degrees. I'm going to use that idea, that triangle rule, to figure out angle 7. So for angle 7, I'm going to say that 52 plus 44, because that's these two, this angle and this angle, plus, let's call 7x for right now. Those together, added together, are going to equal 180. And then we have to solve for that equation. So I combine my like terms. 52 plus 44 is going to be 96. And that's going to be plus x equals 180. I'm kind of flying through this because this is solving equations, which is something we've done quite a lot of. If you want, just pause, rewatch, pause again, until you kind of are following along there. So to solve for x, I'm going to subtract 96 from both sides. If I subtract 96 from this left side, it's just gone. It's 0. So all I'm left with is x equals, and then I have 180 minus 96, and that's going to be 84. Let's try that again. That's going to be 94. Excuse me. And so that's going to be the angle measure for angle 7. So let's put that in there. So I've got, oh, I was right the first time. Let's go back to that, say 84. And that will be a lot better. And let's put that in here for angle 7. So 84 degrees. Well, it's nice to check with a calculator if you're feeling unsure of yourself. Or do it on paper at least. That's always a good idea. So I now know that because of that triangle rule, angle 7 equals 84 degrees. Let's go back to this idea of supplementary angles to solve for angle 8. So angle 7 and angle 8 lie on the same line. And that means that together they have to equal 180. So if I'm thinking here, okay, well, whatever's left over from 180. So 180 minus 84 is going to be the measure of angle 8. So let's put that in. So if I took 180 and I subtracted 84, what I would get here is 96. And let's put that in that space. Because of supplementary angles, I know that. So I know 1, 2, 3, 4, 5, 6, 7, and 8. Now let's go back to this idea of vertical angles. Because 9 is across from 8, it is vertical to 8. I know vertical typically means up and down, but vertical angles means across from each other. So that's just some weird thing that we have to remember. So because angle 8 is 96 degrees, and angle 9 is directly across from angle 8, it also is going to equal 96 degrees. Let's put that in. All right. So now we're getting close here. Let's go back to the idea of vertical angles here. 7, angle 7 is directly across from angle 10. It's vertical to angle 10. So vertical angles are congruent or equal each other. So I know that because angle 10 is across from angle 7, they both have to equal 84 degrees. So we'll just put that in for that. So now I've got 10. Let's go down here. Down here is going to be very similar to what we did up here. But, let's bring in some more vocab here. Let's think about this. So I'm going to use the idea of corresponding angles. So again, go back to your green sheet. Corresponding angles means the same position on the other on the other parallel line. So I'm just going to randomly pick this angle 3 here. And I'm going to say, okay, well, this is on the bottom of the parallel line to the left of the transversal. So it's bottom left. So I'm going to go to my other parallel line, and I'm going to say, okay, well, now angle 17 is bottom left. So it's same position, but the other parallel line. Whenever you're corresponding, whenever the angles are corresponding, they are also congruent. So angle 3 is going to equal the same thing as angle 17. They are congruent because they are corresponding. So angle 17 will also equal 128. Put that in there. All right. Now there's a few ways to think about the other angles here. Let's just go to the vertical angle. So 14 is a vertical angle from 17. So I know that has to also equal 128. 128. And then I can think about angles 13 and 18 in a few different ways. I could go back to my supplementary angle thing, or I could also go back to my corresponding angle thing. So I know that angle 52, or this angle, which measures 52 degrees, is corresponding in the top left to angle 13, which is also in the top left, but on the other parallel line. So I know that that has to be 52 degrees. So let's put that in. 52 degrees. All right. So now we're really flying here, and I don't have much time. I have a minute left before my time runs out here. So I have 52 degrees. Again, vertical angle, so 18 will also equal 52 degrees. And I'm going to try to fly here to make this happen. So 52 degrees there, and get it into its spot. Go to its spot here. Let's go across. Use the idea of corresponding angles, and I'm just going to pick randomly this 44. Is on the bottom left. So I go down to my bottom left here. So I know angle 5 is going to be congruent to angle 15. Those are going to equal each other. So angle 15 also has to be 44 degrees. All right. And now I know that angle 12 is across from angle 15. And when they're across from each other, they're vertical, which means that that also equals 44 degrees. And now I am 10 seconds away from being out of time, so I'm going to have to rush this here. You can look up here to this congruent corresponding angle 136.